Alright, today we're going to be looking at synthetic division. So first of all, what is synthetic division? It's going to be a form of dividing two polynomials in a way that is more practical than performing polynomial long division all the time. There are other uses for it, but mostly it's just to make your life easier so you don't have to go through the whole process and risk screwing up something in the middle of it. So first off with this, we're going to start out with one example where it's dividing 2x cubed plus 7x squared minus 6x minus 8. And then you divide that by x plus 4. So first we're going to set up this problem by putting whatever makes this equal to 0 outside of the synthetic division kind of setup. And then you're going to put the coefficients of each number consecutively right here, and it doesn't matter how many there are. You can do it with like 4 terms, 5, 6, any really, just depending how long you want to take on it. And then second, we're going to start this process. So first of all, you're going to carry down this first number every single time, and then once you've done that, you're going to multiply the outside number by this number. And that will carry over to this right here. So -4 multiplied by 2 is going to be -8. So then you add these terms together, and that's going to be -1. And then you repeat the process where you multiply -4 by this bottom term again, and you're going to get 4. And then 4 plus -6 is going to be -2. And then when you multiply -4 by -2, you're going to get 8, and the remainder is going to be equal to 0. And when we look at that, we're going to rewrite the answer as being 2. I just carried these numbers over here. So this is going to be 2 and then -1 and -2. So the first term is going to be 2x squared, and the second term is going to be -x, and the third term is going to be -2. This is going to vary with like how many terms you use. If you were to be using like 2x to the 6th, it will be different, and you would have to figure that out down here depending on how many terms you end up with. And also you have the ability to have like zeros in here, so just keep that in mind. For my second example, I'm just going to be looking at if you have a remainder. So you're going to do the same process again. Figure out what makes this equal to 0, and that's going to be 3. So you put that on the outside, and then you put all these terms on the inside. From there, you're going to repeat the same process. So you drag this number down, it's going to be 4, and then you multiply this, you get 12. You add those, that's going to be 10. You bring this, or you multiply this by 10, and then you get 30. 30 plus 3 is going to be 33, and then you multiply that by 3 again, which is 99, and then plus a -7, which is going to be 92. And then with this remainder, what you're going to do is you're going to repeat the same process again. So you see that we have an x squared term, an x term, and then a constant. But along with that, you're going to have to include the 92 that didn't get divided out before and divide it by that polynomial, or by the x minus 3. And for my third example, I just wanted to kind of go through this one just because it's a little different with the 3x plus 1. To get that equal to 0, it is going to be -1/3. And just remind yourself of that, where 3x plus 1 is equal to 0, and then you subtract 1 and divide it by 3, and it's going to be -1/3 is equal to x. So you just put that on the outside, and then you have the 3 here, then I get 5, 4, 2, and then you're going to do the same exact process again, and lucky enough, this one comes up to 0, and then this will be the answer. This is really nice if you're doing some like calculated or difficult calculus problems. It's quite difficult to just do polynomial long division all the time when you're trying to get things done. And also, it's just nice to have as a resource.